Hello children, today we are going to revise all the lessons. First I am taking force and pressure. All you know what is force? Pushes and pulls are forces. And what are the effects of forces? Force can make a stationary object move or can change its position of rest. Second, force can change the speed of a moving object. Third, force can change the direction of a moving object. Next is force can change the shape or size of an object. Okay children, now how we are going to describe a force. A force can be described by stating its magnitude and direction in which it acts. A force is represented by an arrow. The length of the arrow represents its magnitude. The direction of the force shows the direction, and the arrow's direction shows the direction of the force. And types of forces, there are two types of forces. One is contact and other is non-contact force. Other is non-contact. Contact forces are of again two types. One is muscular force and other is frictional force. Non-contact are three types. First is gravitational force, second is magnetic force, and third is electrostatic force. Children, now next we are going to discuss what pressure. What is pressure? Children, how can we define pressure? Pressure is defined as the force exerted per unit area. And the effect of force produced on an object depends on two factors. First factor is the magnitude of force applied. The greater the force, the greater is its effect. Second factor, the area over which the force is applied, that is the area of contact between the two objects. So, children, pressure is defined as the force exerted per unit area. From this it is clear, smaller the area over which a force acts, the greater is the pressure, and therefore the greater is the effect of the force. What is the unit of pressure? Unit of pressure is Newton per square meter. We write it like this: Newton per square meter and also Pascal. Okay, and we write it PA. Okay, now there are applications related to the pressure in our daily life. We use this pressure. Now we are going to discuss pressure exerted by liquids. Liquids also exert pressure. Pressure exerted by liquid. Children, liquid exert pressure sideways. Okay, liquids, they exert pressure sideways but not solids. And liquids, the pressure in a liquid increases with the increasing depth. Water pressure increases with depth, and pressure at the same depth is the same in all directions. And how are we going to measure this liquid pressure? There is an instrument, we call that pressure gauge, and the simplest form of pressure gauge is manometer. Now we are coming pressure exerted by air. The air above presses down on us with the force equal to that exerted by a mass of 1 kilogram on every square centimeter. This is called atmospheric pressure. Atmospheric pressure is the pressure exerted on an object by the weight of the column of air over it. As I told you, 1 kilogram on every square centimeter. Okay, and what are the factors that affect the atmospheric pressure? First, altitude. The atmospheric pressure is maximum at sea level. As we go high altitude, the air becomes thinner and the atmospheric pressure decreases. Next is temperature. Air expand temperature. So atmospheric pressure decreases with increase in temperature. Humidity, and also humidity affect the atmospheric pressure. The pressure decreases as humidity increases. Now children, we are coming to the chapter sound. Sound, sound is a kind of energy and it is produced by the vibrations. Okay. When the object vibrate, they produce sound. What is vibration? To and fro motion of an object is called vibration. Children, what is amplitude? The maximum distance by which the bob of the pendulum moves away from the mean position is called the amplitude. Okay. This mean position, the movement is what? Amplitude. The more it go this side. Okay. What is time period? The time taken by the pendulum for one oscillation is called the time period of the pendulum. What is frequency? The number of oscillation per second is called frequency of oscillation. Now what is characteristic of sound? The factor which makes sounds different from each other are called characteristics of sound. There are three factors. First is loudness, second is pitch, and third is quality. So what is loudness? Loudness of the sound depends on vibrating object and on its amplitude. Okay, amplitude of the vibration. Loudness is proportional to the square of the amplitude. Next is pitch. The higher the frequency, the more high pitched the sound. Third is what is quality of sound. The quality of sound is determined by the frequencies present in it and their relative loudness. Okay. Now, which the organ is there for hearing the sound? That is ear. Ear is divided in three parts: outer ear, middle ear, inner ear. Outer ear, it consists of pinna, ear tube, and eardrum. Middle ear consists of tiny interlocked bones, and inner ear consists of coiled organ of hearing, semicircular canals, and auditory nerves. Okay children, we are coming to the audible and inaudible sounds. Audible frequency range is 20 Hertz, from 20 Hertz to 20,000 Hertz. And low frequency sound which we cannot hear are called infrasonics, and high frequency sound above 20,000, okay, we call them ultrasonics. Sound requires a medium. Sound travels in solid, liquid, and gases. The speed of sound is like maximum in solids, lesser in liquids, and minimum in gases. Okay, around 1500 meter per second in water, 5000 meter per second in steel, and 340 meter per second in air. So this is the speed of sound in different medium. Now what is reflection of sound? We call that echo. Sound is reflected from a surface in the same way as a ball bounces from a ball. Okay. Absorption of sound also takes place. Soft surfaces are better absorber of sound, whereas hard surfaces are better reflectors of sound. Okay children, like human being, like sound, the organ that produce sound, we call that larynx. The larynx has two vocal cords which are folds of tissue with a slit-like opening between them. Okay, women have shorter vocal cords than men. Musical instrument, there are three types of musical instrument. Stringed instrument, example sitar, guitar, wind instrument like flute, and percussion like tabla. Children, what is noise? An unpleasant disturbing sound, especially one that is loud, is called noise. Okay. The unit used to measure loudness of sound is called decibel, and we write it like dB. Okay. What are the major sources of noise pollution? The major sources are road traffic, air and rail traffic, neighborhood and domestic noise. Noise from industries, and there are negative effect of loud sound also, like blood pressure increases, deafness can take place, nervous breakdown can take place. So these are the bad effects of sound. Now we are going to discuss children, chemical effects of electric current. Okay. Chemical effects of electric current. First, what is electric current? The movement of electron constitutes an electric current. Okay. We know that the flow of electron takes place in the circuit. We consider the flow of conventional current to be from positive to negative, and the flow of electronic current to be from negative to positive. Now, conduction through liquids. Liquids, they also allow the conduction of electrons. Some liquids, they are good conductors, and some they are bad conductors or insulator. Like distilled water is a bad conductor of electricity, and salted water, tap water, acidic solution, basic solution, salt solution, all they are good conductor of this electric current. Now, what are the different terms we are going to use in this? First is electrolyte. Okay. What is electrolyte? A substance which conducts electricity in the liquid state or when dissolved in water and breaks up chemically during the process is called electrolyte. Second term we are going to use electrolysis. It's a process. The process of breaking up of an electrolyte chemically on passing an electric current through it is called electrolysis. And when electrolytes such as copper sulfate, suppose we have taken copper sulfate, it breaks into copper ion and sulfate ion. Okay. When an electrolyte such as copper sulfate is dissolved in water, it breaks up into positively and negatively charged ions are called cations. These positively charged ions are cations because they go to the cathode, and negatively charged particles are called anions because they go to the anode. Now we are going to discuss uses of electrolysis. First use is electroplating. We are going to discuss electroplating in laboratory. For this, what we are going to take one beaker. Here, suppose we are electroplating iron spoon with the copper. What are we going to do? That here we are going to electroplate it with the copper. So we will take the electrolyte that contains copper. Means here our electrolyte is solution of copper sulfate. Okay. And this always by which we are going to electroplate, we are going to join that electrode with the positive, so it becomes anode. And the thing which we need to electroplate, we are going to join with the negative terminal. So this has become cathode. Okay. So here, children, we will see what reaction takes place. When copper sulfate is dissolved in water, it forms positively charged copper ion and negatively charged sulfate ion. There is no role of sulfate, okay, in electroplating. Only for formation of this is there, okay. When an electric current is passed through the solution, what happens? The copper ions, these copper ions or cations move toward the cathode and pick up electrons. What happens in cathode? This copper ion, they go to the cathode and take the electrons from this, because the electrons, they are moving in this and they pick up the electrons here and it becomes copper atom, okay, and this copper atom deposited on the spoon. And what happens at anode? Here the copper, when the copper and the number of copper reduces, so copper starts coming out from this strip, and what happened? This copper atom from the strip, it removes 2 electron and it becomes copper ion, okay. So these 2 electrons which you are seeing, it moves and it is collected by copper here. So this copper comes out and when it goes there, it collects this electron and becomes an atom again and deposit on the spoon, okay. So this way this reaction takes place here. Copper gets transferred from the anode to the cathode. This arrangement, children, we call this electrolytic cell. Here what happened? In the electrolytic cell, okay, electrolytic cell converts electrical energy to chemical energy. But in galvanic cell, opposite takes place, in that chemical energy converted into electrical energy. Children, other uses of electrolysis is extraction of metal and purification of metals. So 3 uses are there: electroplating, extraction of metal, purification of metal. Now we are going to discuss reflection of light. Bouncing back of light is called reflection of light. There are 2 types of reflection, you know, regular reflection and diffused reflection, okay. What is regular reflection? When the rays in a beam of light fall on an object with an uneven surface, they get reflected in different direction. This is called irregular or diffuse reflection, okay. And when the ray of light fall on a smooth surface, when the rays of light, they fall on a smooth surface, the entire beam is reflected in only one direction. This is called what? Regular reflection. There are 2 laws of reflection. First, this is mirror. When any ray falls, this is called incident ray. Where it falls, we draw normal at 90 degree with the surface of mirror and it reflects back. And what are the 2 laws? First law is angle of incidence is always equal to the angle of reflection. Always equal to the angle of reflection. Second, incident ray, normal and reflected ray, all they lie in the same plane. In the same plane, okay. So these are the laws of reflection. Next is, what are the characteristics of an image formed with a plane mirror? The image formed is erect. The image is of the same size as the object. The image is laterally inverted, that is, right side of the object appears as the left side of the image. the image is as far behind the mirror as the object is in front of it. Okay, and the image is virtual, that is, it cannot be caught on a screen. So these are the characteristics of image formed by a plane mirror. What is multiple reflection? When the two mirrors, when the object is placed between two mirrors and these two mirrors, they are in the certain angle, they are placed in certain angle. Okay, I am telling you again, the number of images formed by mirrors at an angle is given by a simple formula. So the formula is what? The number of images formed when two mirrors are placed at particular angle. So the formula is 360 minus 1 upon theta. Suppose two mirrors, they are at the angle of 90 degree. How many images would be formed? 3 images. And on this principle, on multiple reflection principle, kaleidoscope works and also periscope. Okay, children. Now we are coming to the refraction of light. What is refraction? First we will discuss what is refraction. The bending of light as it passes from one medium to another is called refraction. And you know why this refraction takes place? Because of the speed of light. Okay, the speed of light reduces when it goes from the rarer to the denser medium. So what are the effects of refraction? First effect is real and apparent depth. Like whatever is the real depth we cannot see because of refraction. Like example, like swimming pool, we cannot see the actual depth of the swimming pool. We can see the apparent depth just because of refraction. Now refraction by glass slab. Children, from the glass slab, the emergent ray which comes out, that is parallel to the incident ray but laterally displaced from it. In case of prism, refraction by a prism, when the two refracting surfaces of the glass slab are parallel to each other, the emergent ray is parallel to the incident ray in the glass slab. But what happened in prism? The refracting surfaces are not parallel to each other in prism. So here, because of that, the light ray bend more in the, like we suppose this is prism, it is going, okay, it will not be parallel, it will bend more, okay, and we can see the angle, that angle, by the angle it is deviated, we call that angle of deviation. I am repeating is, the emergent ray is deviated from the direction of the incident ray by the angle of deviation. Okay, and children, because of this deviation, you know, white light is split into 7 colors. It is separated into 7 constituent colors, and this splitting of white light is called dispersion. Okay, this splitting of white light is called dispersion, and the colors which we get on screen, this is called spectrum. Now lenses, there are 2 types of lenses, concave lens and convex. Okay, we are going to discuss image formed by convex lens in a different position when the object is placed at different position. First is when the object is very far. Like when the object is very far, suppose sun, okay, 2 rays we are going to take, trace 2 rays, the path of 2 rays, first rays which is passing through the optical center, okay, and second ray light which passes through the focus, because it is coming from very far. So first it will pass from focus and then it will become parallel to the this, and the image would be formed on focus. Nature of the images, real, inverted, and position is focus, and the size is diminished. Suppose sun is, it's a image of sun, it is very small, so it is diminished. Now just opposite of it, like when the object is placed at focus. Object is placed at focus. What happened? This ray which is going parallel to the principal axis, it will pass through the focus first, and second ray directly it will pass. And children, these rays, they are going and they will meet very far away. Okay, when the object is at focus, the image will form at infinity, and the image which we are, because we are getting this side, means we can get on screen. So it is real, inverted, very magnified, okay, magnified than the object. Now children, second we are seeing when the object is beyond C. When the object is, this is C, F, beyond C, parallel it will go, then pass through the focus. This is C. Okay. Other ray is going, passing through the optical center, will meet here. Okay. This is AB, and we are going to write down A dash, B dash. This is C. So when the object is beyond C, so the nature of the image is real, inverted, smaller than the object, and position between F and C. Opposite of this, when the object is between F and C, when the object is between F and C, after reflection, first ray will pass from focus, second ray will pass from the optical center. Okay. This is F. So when it is between C and F, we will get real, inverted, larger than the object, and beyond C. And when the object is at C, when object is at C, this is F, or 2F, this is also called 2F. We will get the image at C. At C or 2F. This is C, and the size is same, real, inverted, and of same size, position C or 2F. Next is when the object is between O and F. This will pass from the F, this is going from the O. Okay, both they are like moving apart from each other. It means they will not meet this side, and their meeting source is somewhere at the back. Meeting point is at the back side, and this is what? Virtual, erect, and larger than the object, and this work as, at this position, convex lens work as magnifying glass. Next we are coming to the concave mirror. Children, as we know, concave lens concave lens. Concave lens is a diverging lens. Wherever we are going to keep the object, what happens after reflection? This will diverge. Okay, and it seems it is coming from the focus. This ray is coming from the focus. Other will pass from the center, and we know center ray, it is going and it will passing, and here these two are cutting each other, and very small image we will find. Children, wherever we are going to keep the object in any position, we always get the image here very small. Why? Because it is a divergent lens. Diverging lens. Now we are coming to the pollution. Pollution, all you know, if we contaminate water or air, that is not fit for use. We say that this is polluted air or polluted water. Polluted water, the main source of water pollution are sewage. Untreated sewage from homes is often disposed of into river, and that makes the river polluted, and it may cause very harmful. These waste contain many harmful microorganisms, bacteria, viruses, fungi, and they cause many diseases like dysentery, cholera, diarrhea, etc. Okay. Second, industrial waste that is also dumped into the river water. That increases the temperature, and because of the increased temperature, what happened? The gases, they become less. Because of these gases, when the temperature is high, they evaporate. Okay, and because of the dumping of industrial waste, the increase in the river water temperature, I told you already, increasing the temperature is itself a form of pollution. Acha children, third is fertilizers and pesticides. It causes eutrophication, means like insecticides and pesticides and fertilizer. When the rainfall takes place, these they washes, because they are inorganic compounds, and they go into the other water bodies like river or lakes, ponds, etc. There these inorganic compounds are taken up by the algae and all. They bloom like anything, and this is called eutrophication. Okay, and this causes eutrophication, and this is harmful because it cuts off the sunlight, and when the light is cuts off, it is not good for aquatic plants and animals which are living in the water. And second, depletion of oxygen also takes place. These are the causes, effects of this eutrophication. Okay, now what is potable water? Hospital waste is also very harmful. What is potable water? Potable water which is suitable for drinking is called potable water. And in water works, we can make the water fit for drinking. Okay, now we are coming to the air, like SPM, causes of air pollution. SPM, suspended particulate matter, carbon monoxide, excess carbon dioxide, green. Okay, these are the thing that makes the air pollute. Okay, sulfur dioxide, nitrogen dioxide, chlorofluorocarbon, lead compound emitted by exhaust of automobiles are absorbed by our bodies. This is not good for our body. Okay, so how we can conserve air? By planting more trees, by using smokeless stoves. Okay, and we use unleaded petrol, and we use electrostatic precipitator. By these ways we can make the air fit for use. Okay children, thank you, all the best.